So today we are going to be taking a look at how to find the volume of cylinders. Now you're going to find that this actually is not super different from finding the volume of the prisms that we've worked with. We're just going to find the area of the base and multiply it times the height. So the area of the base just happens to be a circle. So we just need to remember how to find the area of a circle. So the volume of a cylinder is the number of unit cubes or cubic units needed to fill the cylinder here, where we're missing an I. Similar to finding the volume of a prism, we can find the volume of a cylinder using base times height. And that big B means the area of the base. So we have, however, there is a specific formula we use for the volume of a cylinder. Let's find it below. So what is the formula for the area of the base of the cylinder? And that base is a circle, so it's going to be pi times r squared. And we're going to replace the b in the formula, v equals b times h, with that. So we are going to do pi times r squared times the height. So our first question down here is one that you might see on the air test or on digits, and they will give you these three different cylinders and they're going to want you to drag and drop them. And it says, what is the volume of each cylinder in terms of pi? And then place the cylinders in order from least to greatest. So the volume of our first cylinder here, we need to do volume equals pi times r squared times height. We're going to do that for all three of them. And a little trick that you'll learn as you move up, so if we say this is 1, this is 2, this is 3, you can put those little sub numbers there so you know which one goes with which. So for our first one there, we are using pi. It says in terms of pi, so that's when we just use pi. We don't substitute in the 3.14. So we're going to have pi times our radius, which is 4 squared, times our height, which is 6. And you can put it in parentheses as well if you like. So I have pi times 16 times 6, which is 96. And then I put the pi at the end, and that is in centimeters cubed. So that is the volume of our first cylinder there. For our second cylinder, we're going to do the same thing. We are going to keep the pi symbol. Our radius of this one is 6. And then our height is 4. So we're going to have 36 times 4. Which gives us 144. Again, we put the pi symbol at the end, and that is in centimeters cubed. So we can see that this one has a larger volume than this one does. And all we did was we changed the radius with the height there. For our last one, we have pi times, we have 5 squared, and we are also going to multiply that times 5. And so we get 125, pi symbol goes at the end, centimeters cubed again. And sorry if I said squared at some point. Meant cubed this whole way through. So we can see that this one is the greatest. It has the greatest volume. This one is the second greatest, and the first one has the least. On our back, we are looking at, it says for an art project, you plan to pour different colored sand into a vase or a vase, depending on how fancy you are, with a volume of 47.5 inches cubed. You have 3 cylindrical bottles of sand. You have enough sand to fill the vase. Explain, and use 3.14 for pi. So since we need to be a little bit more exact here, we want to use that 3.14. So they're telling us that the volume of this is 47.5 inches cubed. So we want to see if adding these all up, if I'm going to fill it. Will I have enough sand to fill it? So For this first one right here, I am going to do, remember the volume is pi times r squared times height. So pi, in this case, we are using the 3.14. My radius, well, if my diameter, so this is my diameter right here, that means my radius is going to be half of that, which is 1.25 or 1 25/100ths. And that will be the same radius for all of them. And you also notice they have the same height, so they're all going to have the same volume. So we have got 1.25 squared and then times the height, which is 3 75/100ths. When I square 3.14, I get when I square 1 25/100ths, I get 1 5,625 10,000ths. And then I'm still multiplying times that 3 75/100ths. We are going to get that when I multiply these three, and you can use a calculator, I'm going to get roughly 18 4/10, and this is going to be inches cubed. Now I have 3 of those, so I'm going to multiply that times 3. When I do that, I'm going to get 55 2/10 cubic inches of sand. So yes, you would have enough sand to fill the vase. You would also have some left over there. All right, on our last example down here, it says a company is designing a can for a green iced tea. The volume of the can will be 15 inches cubed. To the nearest tenth, what is the radius of the can? So this is, you might remember other times that we found the unknown. So we still have the same formula. This time they're telling us that the volume is 15. We know that pi, they're telling us use 3.14. And they want us to find the radius, so we don't know the radius. We do know the height is 4 8/10. This is all multiplication, so I can move stuff around. So I think of it as 3 1/4 times 4.8, and then I've got my r squared back there. And this helps remind me that I can multiply those. So when I multiply those, I get 15 72,000ths. And I'm going to divide by that 15 72,000ths because I am multiplying by it to start with. That means I'm going to get approximately 99 hundredths. It's a big long decimal if you do it on your calculator. And then I've got the r squared. So I'm going to take the square root of it. So remember, the square root undoes the squaring. So I need the square root of this. So this is really close to 1. And actually, if you look on your calculator, depending on how you were rounding, that really would round up to 1. So really you're finding the square root of 1 here. Well, the square root of 1 is 1. Now we could get a positive and a negative there, but we know it's a distance, so it's going to be the positive 1. So the radius is about 1 inch. From here, you're going to complete the Learning Target 1 partner practice questions on Schoology. Make sure you show your work in your math notebook.